Hello everyone, welcome back to my channel. In today's video we are going to find the area of this yellow shaded region, and we know this length which is 6 and this length which is 4. Since we have symmetry along this line, this segment is also 4. If we have a circle and inside the circle we have two intersecting chords, the product of the formed segment are equal. If I call this segment A, this segment B, and this segment C, and this D, you know that A times B is equal to C times D. So now we can use this theorem to find radius of the big circle and the small circle. Let's call the radius of the big circle R. Know that this segment is R, the whole segment is R, so we subtract 6, we get R minus 6 here, and also here we have R minus 4, here also we have R minus 4. So now we can write the product of these segments. R minus 4 times R minus 4 should be equal to R times R minus 6. So if we simplify it, we get R squared minus 8R plus 16 should be equal to R squared minus 6R. R squared can be cancelled out from both sides, and if we add 8R to both sides, we get 16 is equal to 2R. And if we divide both sides by 2, we get R is equal to 8. For the radius of the small circle, we know that this segment is the diameter of the small circle, so we can write R plus R minus 6. We know that the R is 8, so we can write 8 plus 8 minus 6 is equal to 10. The diameter of the small circle is 10, so the radius is the diameter divided by 2, and we have 10 divided by 2, we get 5. So the radius is 5. Now we have most of the radii, so we can use to find the area. The area is equal to pi big I squared minus pi small I squared is equal to pi times 8 to the power of 2 minus pi times 5 to the power of 2, and we have 64 pi minus 25 pi, and finally the area will be 39 pi. So this is the final answer to the problem. I hope you enjoyed this video. Thanks for watching and have a good time.